Hi, my name is Aaron with iBoard Repair and iPhone Data Recovery, and today I have in front of me an iPhone XS. I have it here under the scope already. Um, this is a water damaged phone. I believe it was ocean damaged. I haven't done very much, but I did take the motherboard out of the housing. The top of the battery connector was actually still stuck in here, so I had to pry it out with a razor blade, and it did break the the battery data line right here. So this FBC will have to be replaced, but it's super corroded anyway, and it was probably going to have to be replaced anyway, so that's fine. The other thing I did was I just popped off a few of these VCC main caps over here. I've seen in this area before that when this cap goes bad, it can tend to short the board itself, like very deep in here, so the line itself, the traces may actually be short inside this board. So that's something I'm gonna have to keep an eye out when I think all the rest of main is cleared. Besides that, it's just basic water damage. Hopefully it's not too severe. I think the XS holds up to water a little bit better than the 10 does. Just because the 10 tends to get the racer area, which controls touch, very, very badly corroded to the point where sometimes it's not rebuildable. The XS doesn't usually see that type of corrosion. So I'll go ahead and split this board, and we'll take a look at the inside of it. So one moment while I grab my heating platform. Or you know what, the heating platform's right here. So this heating platform doesn't have any temperature that you set. It just has one temperature that it operates at. With the temperature that it operates at, this board will tend to be ready to lift at about 4 minutes. So I'll turn this on, and I'll put my timer on my phone for about 4 minutes, and then that board will be ready to split. So I'll be right back in about 3.5 minutes. We don't have to sit here together, and we can move from there. Okay, it's been about 3 minutes and 45 seconds, so this should be ready to pull in about another 15 seconds. I tend to like to pull or insert my tool into this area right here, and then I lift right there. I only do that because I know that there's only ground underneath this screw hole here, and make sure I don't disturb the pads anywhere else. Okay, let's take a look at it. I'm very happy to see that there's not much corrosion in here. I expected actually a whole lot more. I wonder if there's any on the bottom board. There's not even too much there either. So if I still have a main short, it's almost surely going to be in that hole that appeared on the top of this board. So even if that's the only thing that I have to worry about, it will be nice to show how I deal with that problem, because it is kind of a unique problem. I'm also going to have to, no matter what, change the battery FBC because it was super corroded and it has a broken battery data line pin. And when you work on the FPC, the battery FPC right there, there's a lot of underfill right like directly above that area, and some things can go wrong in that area when there's heat applied there. I don't often have to remove this shield, so hopefully I don't have to this time. Hello. Okay, sorry about that. I had a customer come in. I don't quite remember where I was at on this. I think I was saying I'm hoping I don't have to lift this shield because I don't usually have to. I just try to get a little glance into these holes sometimes, and it doesn't look too bad. So let's see if we're still main short. Now that the board has been split, maybe the rest of the short was on the bottom board. Nope, still short. So I'm going to inject into main here. I'm going to see if this area over here heats up. Oh, you know what? This cap is also main, so maybe that's the last one. That's still bad. Let me double check on ZXW to make sure which caps are which. Yeah, this is the last main cap over here. That one's definitely looks short. So if I'm lucky, that's the end of the main shorts. Nope, still short. So I'm pretty sure I'm gonna see this board heat up over here in one of these holes that got blown into this board from the heat and the voltage. So I'll inject into main and let's see where the heat goes. Keep an eye out on this area here. That's where I think the heat's going to show up. I don't think that's actually in frame for you. Let me scoot it over. I already lost the area. I think it's here, or maybe it was here. Let's just see where the heat goes. So I think there's heat somewhere else, or a short somewhere else. Even if that's still short, I think there's a stronger short somewhere still. So I'll check the other side of the board again as well. I also want to see if boost is short, so let me check that. Here's a boost cap. Boost is not short, so that's good. So I'll inject in the main on this side and see if we can see any heat over on this side. I'm going to grab more free spray first. This is just about out. Okay, so I will inject into this cap here, and let's see if we can find a short on this side of the board instead. If I don't see anything on this attempt, I'll go back to the other side because I still very much suspect that it's going to be that hole in the board that's really causing me my problem. So this was kind of the area that heated up the first time as well, which is a little odd to me. This is a full-on, full short, so I should have heat somewhere. I'm just going to look at this area right here for the full duration, just so I can be assured that it's not that area and I could get that spot out of my mind. Right here. Okay, this might be it. So let's keep an eye out on that guy this time. Hello. How's it going?
Someone put your name?
Yeah, if you can.
It's cool?
Yeah.
Thanks, Will.
Have a good one. So I think it's actually going to be this cap right here that may have gone bad. It should start to melt right now if it's going to be the culprit. Oh, look, it is starting to melt. There it goes. So this cap revealed itself right there. So that might be my short. Well, it is a short, but hopefully it's my only short. Yep, and you can just see when you remove the underfill that it looks terrible underneath it. So let's see if that cleared the short. Did not, still short. So that was only one of the shorts that's on the board. I'll also just get rid of the caps that are next to them because these do tend to go bad. And that one also doesn't look very good. And then this is also main. That one doesn't look too bad. And yep, that was it. So it's probably this other one that was also bad. So no longer short though. So that's very, very good to see. So I'm gonna have to replace this connector. Which isn't too bad, but it's a little bit of a hassle. What I was talking about before, some of these components, usually these ones are the ones that are underfilled, and these can kind of get messed up when you put too much heat here. But also this guy right here can go bad, and this one controls touch. So if I'm done with this and afterwards I don't have touch, I'm going to have to probably reball this chip as well. It's very common for it to go bad. In fact, I'm probably just going to get rid of some of the underfill on it right now, just to hopefully prevent that from happening. Really glad to see that I didn't have a board short in here, because those are a real pain to deal with. In my opinion, the underfill around this chip causes more harm than good. It's very common for this chip to be lifted because of this underfill. And I very commonly see people asking about no touch when their diode mode readings are fine at the FPC connector. And whenever I see that, I always suggest to check this area, because this component doesn't show up at the FPC when you're measuring diode mode. It just provides power to the chip itself. So hopefully that's enough that I won't have a problem with that chip now by applying heat over to this battery FPC over here. But next I'll just go ahead and remove this. Then I'll clean up the pads a little bit. I'm not super concerned with a perfect connector. I just need it good enough to take battery and to read battery data. So that should be good enough. So I'll pull that connector just from another motherboard that I have somewhere. Let's see if I have it here. Yep, this one looks like it will be fine. This is an iPhone 10 motherboard, but shouldn't be too much of a problem. As you can tell, this connector is already a little bit damaged, but it looks good enough that it'll work, in my opinion. So I gotta turn down the air just a little bit and hope I don't melt this connector. Starting to liquefy. Connector could definitely look better, but I think it will be fine. I don't quite remember if there's an orientation for this. It doesn't look like it, but I dropped it, and I'm not sure if it turned when I did that. I don't think it matters, but I guess we'll see. this solder that I put onto these pads is going to be a little bit lower melt than what was already originally there. So it should liquefy a little bit faster than it did the first time, and there it goes. Now I'll just check to make sure my battery data lines are actually connected. I'm a little bit concerned that maybe this area didn't get all the way connected. It kind of feels like it is. I'm glad I don't see any solder balls around. I'll check the other side. Sometimes I get some tiny solder balls by the PMIC when I work in this area, but not usually enough to harm anything. But I'll double check. So I got a reading there, I got a reading there, and I got a reading there, and this should be ground. So that seems fine. Let's just see how the PMIC area looks. I'm glad to see there's no solder balls, so that was great heat control. And now I expect that this board should be ready to boot. So I can try it top board alone first to see if it boots. Of course, I'm not going to have any touch function if I'm using top board alone. But once I see it boots, then I can grab my jig and I can grab a bottom board, and then that should return touch. Everything else looks okay. So one moment while I grab the small parts for this board. Okay, let's see if this thing's booting. Hopefully there's nothing wrong with my image FPC. So I'm getting a boot, or an Apple logo I should say, but it's not pulling anything from the charge port. Because I made a mistake. This is actually an iPhone 10 charge port, and I'm working on a 10s. So let me go grab the right charge port. Sorry about that. Okay, I got the right charge port attached now, so now I should get an amperage draw from my ammeter, as well as a prompt to boot, and hopefully all the way up to full boot. If I see it's booting fully, then I'll grab my jig and a good bottom board, and then I'll double check that touch works, and once I double check that touch works, then the job's basically finished, and I'll be able to pull data from it. Okay, that's definitely more normal. Now it's pulling a normal amount of amperage through the charge port. I'll pause it while it's booting because it could take a minute or two. Okay, I'm glad I charged that because that did take almost 2 minutes. But I think you can see that. Maybe just barely can't see it. Well, it had booted. Can I get that back without touch? Yeah, there it goes. So you can kind of barely see anything on there, I think, but obviously touch doesn't work because there's no bottom board, but I am getting full boot. So let's go grab the jig now and make sure touch is working, and then I'll be able to pull data from this. So I'll be right back with that. All right, I have my jig here. So I'll place the motherboard into here. We can double check touch. Find my good donor bottom board. I think this is the one I normally use. All right. So hopefully we have touch with no problems here. So 10s and 10Ss tend to be my favorite data recovery jobs. They're just almost always recoverable. I very rarely can't recover from a water damaged 10 or 10S. So I got no touch still. So this isn't done yet after all. So first I'll just check my my pads or my FPC to see if the FPC is giving me normal readings. So I can just do that by testing this thing here. I kind of always get confused about what side's what, so let me just verify what is what on here. So one side should have 3 grounds, the other one should only have 1 ground. There's ground. Okay, I think I know what side's what. So looks like this line might be my problem. Number 4, I'm not getting a reading on. 1, 2, 3, 4. The next line should be ground. And then a beep. And then 2 more grounds. And then beeps. Yeah, so it looks like my 4th pin right here is what I'm missing. Let's just see if it was the jig not making good contact. So let's see if I'm getting a reading on this side, the one that actually goes to the PMIC. It's the sixth pad on the outside should give me a reading. So this one. So this one does give me a reading. I'm just going to go ahead and clean these because there doesn't seem to be anything wrong with the top board. So either my bottom board has a problem now, or this thing is not making good contact. And that's all this job is just continually finding problems and then trying to solve them however you can. It's very, very typical that you think a job's done and then something else crops up. And I'm still not getting a reading there, so I think there might be a problem with the resistor or the filter that's on the bottom board. If I just push on this top board, I should also be able to get some some readings. So let's see if I can determine if it's the cable that's giving me a problem. Nope, I still get no reading there. Okay. So I don't normally diagnose my bottom boards. I usually just replace them, but I don't think I have one that's just like handy right now. So let me just see if figure out what's going on with this one. Looks like that may be damaged. No, that seems okay. So I'm not sure where I'm getting disconnect here. Well, that's really bad. I didn't realize I was working with a board that looks so terrible up here. So it looks like it's just like dried flux in the way that's stopping the contact. It's also possible some lines are not proper. Could have sworn this was the board that I normally use for these transfers, but apparently it wasn't, because I didn't even double check all these problems that this thing's showing up here. One, two, three, four, five. It should be that one, right? No, not that one. That one looks like it's ground. Maybe it's this one. Oh, it's okay, I understand. All of these things up here were ground anyway, so it didn't matter. The sixth one, 1, 2, 3, 4, 5, 6. Alright, let's see if that's good enough. Nope, still doesn't want to give me a reading there. Alright, I'm just going to find a different bottom board because this one's already disconnected. I can see that. That was dumb. So I think I can show you. It looks like it's coming disconnected right there. So that's what my actual problem was. This board just shouldn't have been used anymore. So one moment, I'm going to find a different bottom board. Okay, so I found the board that I normally use. It was right in front of me. So that was dumb. Yeah, this obviously is a lot cleaner of a board. Obviously it's not perfect, but this is the one that works. So let me show you touch working now so I can close out this video and start taking data. I'm hoping to get done another 2 jobs at least today. I'm so incredibly busy right now. So I need to work quickly on almost everything I'm doing. Okay, I didn't test those values at the connector this time, but I don't expect a problem. So let's just see if it's working now. There we go. So it's going to send me to the swipe to recover screen. That just happens sometimes when you're using a donor bottom board. So once this finishes, I will show you one last time, and then I'll close out the video then. Okay, finished up, and it looks like I'm in. Let me double check. And I'm in. I have access to data. This customer is going to be quite happy. In a very standard iPhone 10 job, I had a VDD main short and a connector replacement, and needed to go on the jig after that. So pretty standard. Hopefully you enjoyed the video, and hope to see you next time. Thanks for stopping by.